Hi there, amazing people, students, lovers of chemistry out there. I'm super excited to be here with you on today's episode of Question for the Day. And on today's episode of Question for the Day, we are looking at the concept of balancing a redox reaction in the basic medium. Okay, so we have this question on the screen right now. We're going to take it step by step and then we'll have our final answer. So the first step to balancing a redox reaction in the basic medium is to split the reaction into the two halves and then to identify the oxidation half as well as the reduction half. So to split it, we have the first half being MnO₄ minus yielding MnO₂. And for the second half, we have C₂O₄ minus yielding CO₂. So now that we have split it into the two halves, the next thing to do is to identify which part is the reduction half and which part is the oxidation half. So taking the first half, for example, we have MnO₄ minus, and on the other side we have MnO₂. So we need to find the oxidation numbers of manganese on both sides. That will tell us if it is the reduction half or the oxidation half. So let's call the oxidation number of manganese on the left hand side to be X, since we don't know what it is. X plus the oxidation number of oxygen in compounds is -2 multiplied by the number of atoms of oxygen that we have, which is 4. This is equal to the overall charge, which is -1. So we have X minus 8 is equal to -1. X is equal to +7. On the other side, however, we don't know what the oxidation number of manganese is, so we call it X. X plus the oxidation number of oxygen here is -2 times the number of atoms of oxygen we have, which is 2. This is equal to the overall charge, which is 0. So X minus 4 is equal to 0. X is equal to +4. So the oxidation number of manganese moves from +7 all the way to +4. Now my question is, when something moves from +7 to +4, does it increase or does it decrease? Of course it reduces or it decreases. So that tells us that this has reduced. So automatically this becomes our reduction half and this becomes our oxidation half. So now that we have that in place, the next rule says balance all atoms apart from hydrogen and oxygen. Let's do that. So to balance all the other atoms apart from oxygen and hydrogen, we have the first equation, which is MnO₄ minus yielding MnO₂. Apart from oxygen and hydrogen, the only atom we have is manganese, and it is balanced on both sides, 1 apiece. So that rule is obeyed for this half. For the other half, we have C₂O₄ minus yielding CO₂. Apart from oxygen and hydrogen, the other atom we have is carbon. On the left hand side, we have 2 atoms of carbon. On the right hand side, we have just 1. So we put a coefficient of 2 over here to make carbon to be balanced on both sides. So now that we have obeyed that law, we have balanced all the atoms apart from oxygen and hydrogen. The next rule says balance oxygen atoms using water molecules, H2O, and balance hydrogen atoms using hydrogen ions, H+. So for the first half, we have MnO₄ minus yielding MnO₂. So now my question is oxygen balanced? No. On the left hand side, we have 4 atoms of oxygen. On the right hand side, we have 2 atoms of oxygen. So that tells us that we need an extra 2 to balance it. So that means we need to add 2 molecules of water to balance oxygen. So we have done that for the first half. For the second half, we have C₂O₄ minus yielding 2CO₂. On the left hand side, we have 4 atoms of oxygen, and on the right hand side, we have 2 atoms of oxygen multiplied by this coefficient of 2, which makes 4. So oxygen is balanced, and we don't have hydrogen in this equation, so no need to balance hydrogen. So coming back to this first equation, Let's balance hydrogen now. How do we do that? We have how many atoms of hydrogen? We have a coefficient of 2 and a subscript of 2. That gives us 4 atoms of hydrogen. So that tells us that we need to add 4 hydrogen ions to this equation to make hydrogen to be balanced. I'm sure you're seeing how every step of this equation is being balanced. So for this is the first half, the reduction half, and for the oxidation half, we have C₂O₄, 2 minus, yielding to CO₂. So now that we have all the atoms, we have oxygen balanced and hydrogen balanced. The next rule says balance charges using electrons. So let's do that very quickly. To balance charges, what it simply means is that we need to calculate the amount of charge on the left side and on the right side of both equations, and then we add a sufficient number of electrons to the side that is more positive so that the charges can be balanced. So let's take the first side for instance. The total charge on the first equation on the left hand side, we have a charge of +1 on this hydrogen, and there are 4 atoms of hydrogen ions, so that becomes +1 times 4, plus we have a charge of -1 over here, so we have -1. Altogether it becomes +4 minus 1. This is +3. On the right hand side, however, you can see there is absolutely no charge, no plus and no minus anywhere. So the charge on the right hand side is basically 0. So now the left hand side is +3 and the right hand side is 0. And we need to add electrons to the side that is more positive to make charges to be balanced on both sides. So that tells us that we need to add 3 electrons to the left hand side in order to make the charges to be balanced. So that means now we have 4H plus MnO₄ minus plus 3 electrons, giving us MnO₂ plus 2H2O. So now that we have done that for the first equation, let's do it for the second one. For the second equation, we have C₂O₄, 2 minus, yielding to CO₂. On the left hand side, you can see there is a charge of -2, and on the right hand side, there is absolutely no charge at all, 0. The side that is more positive is the right hand side because 0 is a more positive charge than -2. So that means we need to add 2 electrons to the right hand side to make the charges to be balanced. So that means we have +2E minus. So for the second equation, we have C₂O₄, 2 minus, giving us 2CO₂ plus 2E minus. So now that we have balanced charges using electrons, the next rule says make the charges equal in both half reactions. So let's do that. How do we do that now? In the first equation, we have 3 electrons. In the second equation, we have 2 electrons. To make them equal, we'll simply say this equation multiplied by 2, because there are 2 electrons here, and this equation multiplied by 3, because there are 3 electrons here. So that way both equations will now have 6 electrons apiece. So let's do that very quickly. We'll now have 2 multiplied by 4H gives us 8H plus 2 MnO₄ minus plus 6 electrons will now yield 2 MnO₂ plus 4H2O. For the second equation, we have 3 C₂O₄, 2 minus, giving us 6 CO₂ plus 6 electrons. So at this point now, we have the same number of electrons in both reactions. So electrons can cancel each other out. 6 electrons cancel out 6 electrons. So the next rule says add the reactions together. So everything on the left hand side here goes with everything on the left hand side, and everything on the right hand side here goes with everything on the right hand side. So let's add them together. So adding them together now, what we end up having is 8H plus 2MnO₄ minus plus 3C₂O₄ minus yields 2MnO₂ plus 4H2O plus 6CO₂. So we've added both reactions together. Now at this point, this is where we convert into the basic medium. How do we do that? The next rule says for each H plus or hydrogen ion in the equation, add an equal number of OH minus to both sides. So for instance, if we have H plus on the left hand side, what the rule says is that we are going to add an equal number of OH minus to both the left side and to the right hand side to neutralize the H plus ion. So let's do that very quickly. Now we have H plus ions on the left hand side and there are 8 H plus ions. So that means we will need to add 8 OH minus ions to both sides. So that gives us 8H plus 8 OH minus plus 2MnO₄ minus plus 3C₂O₄ 2 minus, giving us 2MnO₂ plus 4H2O plus 6CO₂ plus 8OH minus. I'm sure you're seeing how every step is being taken. So now the next rule says wherever H plus and OH are on the same sides, combine them to form H2O. So now we have 8 H plus ions and 8 OH minus ions here. So the rule says combine them to form H2O. When we have 8 OH plus plus 8 H plus, it gives us 8 molecules of water. So now what we have is 8H2O plus 2MnO₄ minus plus 3C₂O₄ 2 minus, giving us 2MnO₂ plus 4H2O plus 6CO₂ plus 8OH minus. So now that we have done that, the final rule says cancel out any water molecules that appear on both sides. So let's do that very quickly. So this is the equation that we have. Are there any water molecules on both sides? We have 8 water molecules on the left hand side, and on the right hand side we have 4 water molecules. So 4 water molecules can cancel out of 8 water molecules. What we'll have left is 4 water molecules, because it's just like saying 8 minus 4, which will give us 4. So now that we have cancelled out the water molecules, let's write out what we have as our final equation. We have 4H2O plus 2MnO₄ minus plus 3C₂O₄ 2 minus, yielding 2MnO₂ plus 6CO₂ plus 8OH minus. This is our final balanced equation. Now when we've balanced a redox reaction like this, we need to check if atoms are balanced and if charges are balanced as well. So let's check if atoms are balanced and if charges are balanced as well. So to check if atoms are balanced, how many elements do we have? We have hydrogen, we have oxygen, we have manganese, and we have carbon. On the left side, how many atoms of hydrogen do we have? We have this over here, which combines a coefficient of 4 and a subscript of 2. 4 multiplied by 2 gives us 8 on the left hand side. On the right hand side, we also have 8 hydrogen atoms because this coefficient of 8 affects this hydrogen as well. So hydrogen is balanced. Oxygen, on the other hand, we have oxygen over here which has a subscript of 1. No subscript means it is one atom. Multiplied by this coefficient of 4, that gives us 4 atoms of oxygen, 4 plus. Over here we have oxygen having a subscript of 4 and a coefficient of 2. 4 multiplied by 2 gives us 8 plus. Oxygen over here has a subscript of 4 multiplied by coefficient of 3, which gives us 12. So 4 plus 8 plus 12 gives us 24. On the right hand side, how many atoms of oxygen do we have? We have oxygen over here having a subscript of 2 and a coefficient of 2. 2 multiplied by 2 gives us 4 plus. Over here we have oxygen having a subscript of 2 and a coefficient of 6. 2 times 6 gives us 12. And then we have oxygen having a coefficient of 8. 4 plus 12 plus 8 gives us 24 as well. So oxygen is also balanced. Manganese, over here we have 2 atoms of manganese because of this coefficient of 2. On the right hand side, there are also 2 atoms of manganese. So manganese is also balanced. For carbon, we have 6 carbon atoms because there is a coefficient or a subscript of 2 and a coefficient of 3. So 3 multiplied by 2 gives us 6. And over here we also have 6 carbon atoms. So carbon is balanced as well. Now that we have checked that the atoms are balanced, let's check if the charges are also balanced. So to check if charges are balanced, on the left hand side you can see there is a minus sign over here which signifies a charge of -1, and it has a coefficient of 2. So that becomes -1 times 2 plus. Over here we also have a charge of -2. We have -2 and it has a coefficient of 3. -2 times 3. So altogether we have a charge of -2 plus -2 times 3 gives us -6. Altogether we have -2 -6, which is a total charge of -8. On the right hand side we have a charge of -1 over here and it has a coefficient of 8. So we have -1 times 8, which is -8. So all the atoms are balanced and the charges as well are also balanced. For the sake of clarity, let's write out a final balanced equation. 4H2O plus 2MnO₄ minus plus 3C₂O₄, 2 minus, yielding 2MnO₂ plus 6CO₂ plus 8OH minus. This, my friends, is our final balanced equation. I'm sure you enjoyed every bit of this and you'll be looking forward to more episodes of Question for the Day. Up until I come your way, my name is David, and all I do here is to take the mystery out of chemistry so Chemi can make history. I will surely see you in the next video where we tackle the next big question.